Good morning, everyone. So my name is Bjarman, and I will be moderating this first session. There are 4 presentations and a Q&A. And we start with Richard Land from Bodleian Libraries, who will be presenting ARCHiOx Part 2, bringing to the digital collection.
Thank you. Good morning, everyone. I've been introduced, so how do you turn on? This one. The one at the top. Right. Can you hear me now? Right. Morning, everyone. I've been introduced, so I'll begin. Today I'm going to talk to you about Phase 2 of our ARCHiOx project. Phase 1, which we had the privilege of presenting at the Naples conference 2 years ago. For the benefit of those who don't know what ARCHiOx is, ARCHiOx stands for Analysing and Recording Cultural Heritage in Oxford. It's a collaboration between the Bodleian Libraries and the Factum Foundation in Madrid, and it's funded by the Helen Hamlin Trust. In Phase 1, Factum sold us an experimental rig and lent us another rig. The experimental rig was called the Sultan, which is pictured here, and the other rig was an older model called the Lucida. And basically, the first one, which I'm going to focus on, is the core technology that we've used for the ARCHiOx project. It's a photometric stereo machine, and we started collaborating with Factum with the aim to use photometric stereo to see the unseen. That was the tagline for the project. In a variety of flat objects that have scratch marks on them, or such as corroded copper plates or dry point inscriptions like manuscripts, to basically allow us to gain new insights into familiar objects that we had in the Bodleian and other collections around the university. In principle, the Sultan works by capturing a photo from 4 illuminations, and then the processor that Factum wrote combines those into a normal map and an albedo texture. And it takes a tile and it moves the camera, and it takes another tile, and then they stitch those together to create a larger composite. And if you see on the right, we create a derivative depth map from the normal map, which allows us to then create a physical facsimile of the object as well as a digital facsimile. And you can see here that this is Factum's Adam Lowe. He's putting through a 3D printed copper plate based off an ARCHiOx picture, and he's putting it through his Goya press. And you can see here he's managed to create a reproductive print from a copper plate that was last used 313 years ago. So not only can we create digital facsimiles, but we can create physical ones as well from really tiny details of 30 microns. I'm going to focus on the digital facsimiles because that's basically my job. So the technique produces all these derivatives. We've got the albedo texture at the front. We've got a composite render, which brings out the details next, and then we've got the depth map and the normal map. Now, how could we surface these in digital Bodleian? Well, if you remember my talk last time, we used IIIF choices to annotate the different variations of the same view onto the canvas. I think this is a video. No? You can see here in Mirador 3, you've got the choices appearing in layers, the layers dialog box on the left there, and the user can mix and match those by using the sliders to change opacity and things like that. But what else could we do? We wanted to basically relight the scenes, use the normal maps and the albedo textures, and then re-render those in real time to allow you to drag a light source around in the viewer to illuminate scratches in real time. And in order to do that, the machine needs to know what it's looking at, and there wasn't a way for it to tell whether a image being loaded was a normal map or an albedo texture or anything like that. So Andy Irvin came up with a Prezi 3 extension that we could feed in to the image service that basically tagged those textures to allow us to know what they were. And this was the state of play at the Naples conference, so this is what the viewing experience looked like after months of development in Mirador and figuring out how it worked. This is a particularly beautiful embroidered Bible, I think. And this is 10,000 pixels across, I think, as well. So it was pushing the limits of our QA stack. So since then, we've received more funding from the Helen Hamlin Trust to take part 2. And I'll just quickly go over what the goals of that project were. Our main goal during phase 2 was to transform this experimental idea into our business as usual. We'd already integrated it into digital modeling, but we needed to figure out how do we get the hundreds of objects that we've digitized into our digital modeling, because we were doing it manually for a couple of examples on QA. And that seemed, we knew it was going to be difficult. We didn't know quite how difficult it's going to be. By the end of the project, we only had 16 objects up, because we had to do a lot of wrangling with them, but I'll go over how we solved those problems. And if you scan this, you can go directly to the collection in digital modeling. And this is a quick video showing you how to find it. If you search in the search bar and open an ARCHiOx object, you can go to the dialog on the left, click down, view in Mirador, and because of our lighting extension, it knows that it's an ARCHiOx object and to enable the plugin. And you can relight it. And there's a bunch of other options which I'm going to talk about in a minute that we've added since Naples. That's a wax seal, by the way. Part 2 also introduced photogrammetry to the mix, thanks to Factum. And these objects have all been placed on Sketchfab for now. We've got over 144 objects that have been digitized. There are various different things from the university, but mostly they're scans of actual books and manuscripts. A couple of busts in there, a few statues. The majority of these have been scanned using their lean photogrammetry setup that I helped out with my spin-out company. But basically they've just got an automated turntable and 2 lights and a dolly, and that's all they've got. And the idea is that we're leaning on their expertise as photographers rather than trying to replace the photographer with an fully automated device. Combining their experience with the ability to take hundreds of photos really quickly, they were able to digitize over, like I said, 144 objects. And what they've done, this is a particularly good example of the stuff that they can do. They basically created physically based rendered textures. So it's a bitmap basically that obscures part of the object that's metallic and part of the object that's not. So it allows the render to render parts of it smooth and parts of it in a metallic way. And I'll show you. This is a Bible that we've got, which has got basically encased in metal. It's got ivory on the front as well. And again, you can scan this and it will take you directly to the Sketchfab collection. That's only a temporary solution because we all heard the news about Sketchfab. So I'll move on to some of the improvements that we made to the viewer. One of the first things I noticed was when I was getting into the nitty-gritty, why were Factum so annoyed at me about the quality? And it turns out that something completely normal was going on. We normally in digital modeling we surface our images in JPEG, And so what you see here is you've got compression happening on the normal maps, and we absolutely don't want that to happen with normal maps, because normal maps are a two-dimensional representation of 3D data. So you don't want it to average the pixels and plumb them to their nearest neighbors, which is what you can see here, very blocky when you relight it. So that was the first thing I began to tackle. You see here an image that demonstrates the lossless compression that happens to images when you basically remove information from them. So how did I sort this out? Luckily IIIF allows you to choose the format of the image that you would like to use in the image API. So we basically started with ping, but ping is too cumbersome. It was great, it looked great, but we didn't want to put it on our production server and have everyone requesting everything in ping. It's just, the file size was just significantly greater than anything else. So we did a bit of research and we found that WebP was probably the best one because it had sizes equivalent to JPEG, but without the lossless compression. So I quickly looked around to see if the things we were using supported that. In theory they did. Our image server, I needed to do a quick update to add in some of the software that IIP image can use to process WebPs. It was a little bit, I think there was something broken, but I immediately chatted with Ruven, and he fixed it in like 5 minutes. I was shocked at how quickly he fixed WebP for us. It was like, I think it was like the next day there was a release. And then I had to fix something in OpenSeaDragon because OpenSeaDragon hadn't added WebP to its list of supported formats. So no matter what I tried to do, OpenSeaDragon kept serving me JPEGs. And it took me a little while to figure out what was going on. It's just a literal list that you could just add WebP to and it would start working. So that went into version 5 of OpenSeaDragon. We also fixed some of the stuff where you rotating the canvas was broken in OpenSeaDragon for years. And we fixed that because we wanted people to be able to move it around in our viewer using the R button. And you can see here, after a few weeks work just to add one property, we've got no lossless compression going on here. So the next problem that we came across was the difference between formats for normal maps. You've got DirectX and you've got OpenGL. Our technology uses OpenGL. Factum's technology uses DirectX, and also the imaging studio was shooting objects on their side. So you end up with the directions and the normals all over the place depending on which object we're looking at, and that is the reason why we've only got 16 objects up at the moment. Because we had to physically inspect all of these and go back to the studio and get them to redo them. We've got a solution to that which I'll go over briefly soon. There was another bug that just happened to appear in Chromium. Chromium apparently at the time, I'm not sure if this is still the case, but if you try to use content negotiation to request version 3 images, if you've already visited a version 2 image, which we've normally got in Digital Bodleian, it caches that and the URL's the same, right? So even if you use the options headers to request a different image, it'll still give you the JPEG. So we were wondering why we were getting a black screen every time we tried to re-render, and that was why. So basically we had to turn caching off, and it worked immediately. But that took way too long to figure out. We wanted to add in new features to the plugin as well. So we, like I mentioned earlier, the studio have been playing around with physically based rendering. It's basically a video game standard for creating all sorts of different materials that represent, it creates a more true representation of the object you're looking at. So what we wanted to do was try and add that into our lighting extension, which we did a bit of experimental work on, but that's not active at the moment. So instead I added a bunch of sliders into the plugin so that people could choose their own values for that shader. The idea in the future is we're going to try and upload different types of texture using our lighting extension to allow people to load something up and it correctly renders it as a metal or a mixed object, like metal and ivory or whatever. So we're going to use Getty control vocabulary to describe somebody's properties, but I think we need to discuss this with other people in the community to see what's appropriate, what we should control with IIIF and what we shouldn't control with IIIF. So here's an example of our prototype expanded lighting extension. You can see in there we've got the ability to feed in the normal map format, so we can tell, the machine can tell whether it's one or the other, because you don't want to do that on the fly. We made a few optimizations to the user interface. It now fits on mobile screens after Thomas Flynn complained at me that he couldn't look at it on a train on his mobile phone. So we made it work on a number of browsers now, and sizes of screen. And you can see here we've got different rendering modes as well. We've got physical-based rendering and something called specular enhancement mode, which is basically just it highlights, it creates a larger contrast so you can see the details pop out more. Another issue with people seem to ignore the layers in Mirador, so we load the screen up with the drawer pulled out so people can see them by default, and also we've got a button on there so that you can click it from the plugin and just cycle through which is the current layer that's active, so you can have a look at those quickly. Yeah, we've got the ability to move between the different shading modes here. We've got better gradations on the control so that people can drag it to have more control over what angle they drag the light to. We've got a helper in the middle, this little blue thing, if you can see it on the right, on the right of the screen. This allows people to see where the light is coming from, because sometimes it's confusing. Especially if this helped us with the normal map issue as well, to check that the lights are in the correct direction. And here's a video of the state of it now, currently. Since the end of the project, I've upgraded the version of Mirador that we're using, because they released a patch version of version 3, which fixed an issue with the, I think people might be familiar with this one. The logo was broken for a long time. It was in the wrong place, so every time you try to validate your manifest, it would say it was not version 3. So that's been fixed, and that works in Mirador. And also, I think the choices view was broken as well. If you try to serve it choices, it would open it up like a book, and that's fixed as well. We've also moved over to Vite, because that's the new thing that they're using to build Mirador with, in anticipation that we'll get it working with Mirador 4. And if you want to look at our repository for this, you can scan this here. I'll leave it for a second. But I wanted to save the best till last. We've got this tool that we've developed with Factum that allow people to create a static version of this and play around with it themselves without much expertise. It's called IIIF Static Choices. It's based off the work of Glenn, who created a Java tile slicing thing to create an image API 0 service. And we've taken that, I've translated it to Python for the back end, and Factum have added a Node.js GUI that abstracts the whole process and allows people to interact with it. And here is the GUI. It runs in a Docker container as well, so you can just boot it up on your laptop and it should just work. The idea is that you just drag in a normal map and a albedo texture in the top. If you type in some metadata for the manifest, here's an example here, and then you press generate viewer, and what it does is it chops up all the tiles in version 3, creates a version 3 manifest, and then you can open it up in your browser. But you can also export the whole static data set and just pop it on your HTTP server, and it should just work. So it bundles in Mirador with the plugin as well. And this is the view after a few minutes. This is quite a big image, so depending on the image size, it'll take a shorter time than this does to process, because this is like 10,000 pixels across. This is an RTI of a ammonite fossil that has been stitched together using photogrammetry software. And if you want to go to the repo, it's here. And then I'll briefly go over some of the work that my colleagues have been helping with. Tim on our team worked with Ruth, the project manager on this, and they took a bunch of users to test the plugin. Some were experienced with the project, some weren't. We got some great feedback on how we can make the user interface more intuitive, so that's the next target for this, for us, is to make we want as many people using this as possible and find it easy to access and use, gain benefit from. And here's some of the ideas that we're going to implement in our GUI. We're going to add in different types of icons that make more sense to people, put things in locations that are more make more sense to people based on the user testing. We want to figure out what we want to put in the final version of our, or the working version of our lighting extension, and also I think I would like to register it as an official thing so that people can find it and know what it is. I mentioned briefly earlier that we've got the photogrammetry collection on Sketchfab, and that's temporary, like I said, and we're going to be thinking about how do we present 3D images on through our digital Bodleian, whether that's using another viewer or whatever, but we're basically going to be basing it on the work of the 3D group, so we want it to be fully tripwire across the board. And I'd like to thank everyone here and the conference organisers and these wonderful people that I work with.
Thanks so much, Richard. We'll go now to the second presentation. So Nuha Subhi from Sultan Qaboos University will be presenting Advancing Sustainability and Accessibility in Marine Spatial Data Infrastructure 3 IIIF, Innovations and Lesson Learned.
Good morning, everyone. I'm so happy to be here today to present my topic, which is Advanced Sustainability Accessibility in Marine Spatial Data Infrastructures, which is MSDI through IIIF. The main ideas I will be presented here is introduction to the marine spatial data infrastructures and IIIF, the challenges in the current marine data management, and the role of IIIF in addressing these challenges. Real-world case study, which is Oman, accessibility innovations and future directions and recommendation for IIIF organization. So, here is mainly focus for the what is marine spatial data infrastructures. Actually, it is a globally framework have been done for all countries have a long coastal area, and it is follow up with the 14th goals for sustainability development. And it is required by the IIHO, which is International Hydrographic Organization, and IMO, which is International Maritime Organizations, which is currently mainly care about the marine area. The needs for that is 80% of ocean data is soiled. This is reported by the UNESCO. There is a critical consistency regarding to the climate real way, especially for Oman, because we are affected a lot with the cyclones is coming from the Indian Oceans. And about the IIIF rule is how it is MSDI is came with the IIIF standards is like recording and presenting different kind of data in a proper way with the metadata of this data. So this is figures is showing where the marine data gaps essentially, and we didn't have that much data regarding. Essentially, I will be focusing in our area, which is invested area, Indian Oceans, which is Oman is nearby. So we have like, we didn't have that much data. Oh, I'm sorry. We didn't have that much data regarding to that. So here is showing how these marine spatial data infrastructures will be helpful. The people who is caring in the research area, who is working in the ships also, and any types or any sectors in a way, and who the community and stakeholders will be actually benefits from the marine spatial data infrastructures. So, and here is what is the sensibility challenges we have in MSDI. We have actually, MSDI is like 4 pillars. First, I need to say is technical governance, the data and the standards. So we have like in technical, we are focusing in GIS format, which is caring about different kinds of data format extensions, like XYZ, ASCII files, and so on. And we have the legacy systems incompletely with the modern tools, because technology every day is changed, and there is a lot of software actually is happens with regard to the open software, open source software or enterprise software, and we have socially and equally accessible for the deploying with the reverse radius, and environmentally we have like no engagement with the most of people. We have like troubles or a lot of problems is occur in the environmental area, especially for the marine. So IIIF how is introduced the solution for these types of data. It is suggestions like most of you is calling about or saying or discussing this data about interoperability. How we can standard API or image processed in API, which is actually most of the countries is nowadays go for this area. And also lightweight work with the low bandwidth, which is gone to the ships area and so on, and reach innovations, which is the tag for the marine species with the different kind. So the show these figures, which is appearance, is show some of the data actually we need it, and most of the country think how this data will be available to make the safety, marine safety or marine navigation for all people who is working in marine area. So IIIF will be enable viewing, comparing with the historical and modern. This is one of type of data, which is coral reef images, and we have like a different kinds of images, like historical chart. We have like a different kinds of data related to the animal, different types of species. So it's not caring about one type of data is available in the marine area. This is the figures show the how IIIF will be bridge different kind of technology in one area. In API and sensors, because we need like different sources from satellite, from drones, from labs, from end users also itself, because it's not focusing only on the research area, also it's focusing in the industry area. All we are different kinds of stakeholders who use these services should be involved in marine spatial data infrastructure. So this is one of the case study I will present later, which is 3D oceans, ocean mapping. Actually, this project is not yet published, but have like how the bathymetric data, which is importance for the coral reef, especially in Oman. We have a lot of coral reef and different kinds, is not available in whole the world, and how the IIIF will be help us for the basic delivery. This one published the web GL for them, and the impact will be 40% of fastest disasters response, which is oil spills, because we have like a lot of shipping truck in our area. So AI and IIFA for marine analysis, how this will be helpful for the special species detection in our area, and how it's working with the specific algorithm which is Yola and CNN to detect these types of species, and will be the result actually expected 90% accuracy in real-time coral health monitoring. Regarding for the accessibility innovations, for more visual impaired, IIFAs can be ultra text annotation for the screen readers, which is already done for land area, but we can move it up for the also marine area. For low bandwidth solution can be region of interest, like load only for the coral sections. The community will be needed for workshop for the coastal, for different kind of organization. Future directions is we need for standards, absolutely, how the IIFA will be profiled for marine data. And for policy, we need IIFA to adoption in UN ocean detection, which is from 2021 to 2030. And regarding to technology, we have like IIFA and VAR, VR, virtual reality for visual device simulations. This is IIFA a marine competency checklist. Actually, I done it this one, but I don't know if they are agree me or not. I divided in multi-case, as it's shown here, is for the marine competency checklist for vessels and equipment documentation, for catch reporting, for legal environment and crew training and awareness, and submission and audit. All this is available actually in the standards of the marine special data infrastructure. So the recommendation for the IIFA is absolutely, we have like most of us is using the open source software, which is Quantum GIS, and how we integrated with the GitHub to store all this data easily, because the funding nowadays is so tricky for most of our organizations. How we can help ocean conversion check? So I suggest this check out. So be a smart and consumers, reduce plastic waste, which is almost, we are saying always time. Use ocean safety product, lower your carbon front end, speak up about these problems, and finally learn and share this experience. In conclusion, I said IIFA can be made MSDI stability and inclusions. Call for action, we need to join for the GitHub repo on the IIFA MSDI best practices, and the partner for the marine lab test with IIFA. So thank you for that. I need to replay something for all to see what I'm discussing about, how we can present this data in the globally H1. Actually, this project is not published yet, but I'm so happy to show you what I'm done it. I'm doing this one integrated different kind of technology. I use ARCHiOx enterprise software with the Quantum GIS to present a different kind of marine. As it is and integrated with the Apache Tomcat, which is Java-based applications. For a database, I use open source database Solar with the HB databases to store the data, and for the rock and wreck data, I use Access database. So to present the data in a different kind, as is shown here, is will be open with the base map with the different kinds of data. Each of these data already built up by the ArcGIS, the metadata of it. So the user can be search with the different kinds of area like line, point, polygon, and we can be check all these data in a different way. So if you need to check a specific type of data, you can choose the layers above and generate it. And the good one is it can be detected different kind of language. Like in our area, we use English with Arabic, so is valid like that. We can use by the query also, so you can check the whole data on it. Also on this, in this platforms, I use integrated with the other website, but it's not showing here. This is the metadata of specific layer. There is also, I link some PDF. I didn't, I do now scan the historical chart to put this, but it takes time for me because digitizing the chart is not look like only using OCR is needed like a specific type of software. And in our area we use Caris software. I don't know if I'm saying a lot of software, but it is in the side of marine we use a specific type according to the standards. That's what I have, and thank you for listening. Take a look.
Thank you so much. So next up we have Jason. We'll be presenting implementing IIIF towards a large-scale image-native archival resources management system.
Good morning, everyone. Hello. Yeah. Good morning, everyone. Nice to be here for the second time, precisely, because 2 years ago, I managed to record a lightning talk in the Harvard MIT event. And that time, we published open source IIIF software called E2CRT. I don't know if any of you use that. No? Oh, I see. But today, there's another surprise. Well, it will be in the end of this PPT. Today, I want to say something about how to leverage IIIF in a very large-scale image-native architecture resource management system. There are 4 parts of my speech. First, the work began in early 2027 with the goal of collecting and preserving Chinese scientists' archival material, particularly those in poor condition and privately owned. In October 2023, a project member interviewed a close friend of Chen Taoshan, founder of modern industrial microbiology in China, and we obtained valuable family archives. Additional material were later gathered from Shanghai Municipal Archives and the Shanghai University Archives. As the collection expanded, the need for safe, efficient workflow to manage and interpret this material became increasingly urgent. While traditional archive workflow are insufficient to meet demands of modern archives management. This is not only due to the unreliable manual processing and the cataloging, but also the fragmented use of independent tools for different archive tasks. In addition, traditional workflow lacked the granularity needed to review the full depths of archival content. But in the meantime, the authenticity and the security of the archival data remains, which is key to archival management. Therefore, the research goals for this project are design and implement an IIIF-based OCR environment to support archival transcriptions, recognition, comparison, and description. Formulate a workflow for managing scientists' archive, organize scientists' archives, photos, literary works, monograph, patents, and the relevant documents. And build classical RAG and graph RAG to deeply mine and analyze archival data. In case you didn't hear the word RAG before, it is retrieve augment generation, which is a process to try to lower hallucination when you deal with large language model. That is, we are trying to use AI in our process. In the scientist archival data development workflow project, the main research path is from physical form of archives, then to digital archive images, then to textual archive data, and finally converted to archival knowledge. The workflow began with digitizing physical archives and records, utilizing high-resolution scanner to convert archival documents, photographs, and other archival materials into digital format. These digitized files were then organized and cataloged using the open source archive management system, ARCHiSpace, which structured metadata and the standard archival descriptions to enhance data retrieval and operability. During this process, raw material were integrated through IIIF objects and recorded as digital objects instance corresponding to their physical items. ARCHiSpace is an open source browser-based archival information management software application. Actually, I think it's very popular in this in archive realm. Use archival images as archive data posed several technical challenges, including handle large quantities of data, large quantities of images, managing complex image-text interaction, ensuring description accuracy, and maintain archival security when employing ARM. To address these challenges, the project adopted the IIIF framework as a standard, breaking down images development into 3 independent yet progressive workflows. The project implemented an IIIF API as a compliant image server base and utilized IIIF presentation API for object-based encapsulation and OCR text integration. So our major creation is to really integrate productivity tools curators normally use in our daily work. That is the office, right? Like Excel, Word, these tools you use for most of the time of your work. But we figured out a way to integrate IIIF framework into normal workflow of everyday life. So we think this might be promising. Archival data, including unstructured data and structured data, they both were transferred into a more like structured IIIF-based form. So traditional menu description tasks are thus converted into data mapping tasks that can be automatically converted by LLM, which is the large language model. The high-quality electronic archival database can serve as a private AIGC, which is AI-generated content database for classic RAG or graph RAG needed by the LLM, targeting at content mining, content analysis, and other tasks that can reveal the value of the archives. Well, this is a comparison between classic RAG and graph RAG. Basically, classic RAG focus on using a vector database to convert all the images into vectors and then select them when needed. But graph RAG use more advanced technology like knowledge graph, which is to organize all those knowledge into a node and some edge, which represent meaningful entities in their relationships. So the overall result, especially for some global understanding, graph RAG is much better than classic RAG. Apart from the chat function, we also build based on the RAGs. We developed a variety of visualization solutions for available archives to facilitate follow-up research, to scientifically extravagate and analysis archives. To conclude, as we enter the AGI era, archival and records management is undergoing a profound transformation. The project has demonstrated how to combining IIIF, OCR, and the large language model with human-machine collaboration can create a pioneering workflow for native image-based archival data. These innovations have markedly improved the efficiency and accuracy of archival processing, offering both theoretical insights and practical benefit for the field. However, maintaining the integrity and trustworthiness of archival content demands strong validation framework. Human oversight remains essential in reviewing and verifying automated output, ensuring the preservation of historical authenticity. This hybrid approach not only safeguards cultural heritage, but also lay a robust foundation for the future scalable, intelligent archival system. Well, that's supposed to be end. but there's a Easter egg. Well, as part of our gratitude to the community, we decided to publish one of our tools, that is the E2 for Office for Excel, to the community. These tools help us to aggregate the metadata of your manifest files and figured out a way to do the easy mapping from image to your metadata. I also actually, this is the begin. So if you want more sophisticated feature, you can either contact me or do it yourself. It's not very difficult. Yeah. Also, I can show some example of how we use it in other projects. This is a real project. This is a real project that is trying to manage the metadata of 10,000 of ancient Chinese paintings. Well, this is a very typical office environment. But I need to install to enable the plugin with customized content. Okay, save on the desktop. Maybe we can see another example. That is also a combination of IIIF and some ancient scripts. Well, in this example, what I want to emphasize is that we use a lot of cloth IIIF, which is Matt demonstrated yesterday. That is, in my view, a lightweight viewer of IIIF. The benefit for it is that it can very effectively do the mapping. That is the key of IIIF. That is, you can map your keyword, especially the search result, to your images. Okay. That's it. Come on. Yeah. So now it will be very easy to do the metadata editing, right? You can even select multiple files and compare the details. That's it.
Thank you so much. And now for the last presentation of this session, presentation titled From Physical Library Catalog to Annotations in IIIF Using AI by Fredrik, Bjarman from Uppsala University Library.
So, hello everyone. My name is Fredrik from Uppsala University Library. I'm here for the first time. Really happy to be here. This is my first presentation in the conference ever, and I'm pretty nervous, so you'll have to bear with me. And I totally empathize with Jonathan Cates's words from yesterday about the imposter syndrome when speaking in front of so many experts in this field. Okay, so this is the project case 62 to Libris, which is, this is our current project team. None of us has worked with AI, OCR, HDR or IIIF prior to this project, but an idea emerged and we sort of ran with it. So this is the story of an ongoing project, my library. The challenge was to make invisible collections visible. The Catalog 62, as you can see, is a physical, mostly handwritten catalog with books, journals, periodicals, and dissertations from 1790 through 1962. It's 130 shelf meters of handwritten and/or typewritten volumes, and the catalogue is in 3 parts. There's an author index, then there's the periodicals and departmental publication theses and dissertations. These were all scanned sometime during the 80s in pretty low quality. And they're actually not card catalogue, but rather sheets of regular paper. And the librarians have used Prussian catalogue rules, which imposed a problem. I'll show you a bit of why. The Prussian rules, well, this is a perfect example of a really nice scanned sheet. The author is on top of the page, several titles on the same page, shelving signs in the margin, an accession number in another margin, place of publication, year of publication, size, number of pages, information, and so on. But most of the pages look more like this. Very difficult handwritings, and some of it typed as well. So, a pipe dream, or can we do this, was one of the questions that arose. So this is what we're aiming for. We've digitized images of the catalog pages, AI to do the transcribing and segmentation, and then we get the results in XML, which we then would like to transform into IIIF suitable manifests and annotations, but also as the main goal of the project is to push this data up into the National Library database as well, so that people can find the actual books that are referenced in the catalog. After trying out some AI framework and models, both proprietary and open source, we decided to use Kraken and Logi. Kraken has been around for quite some time, and I think it's well known in the OCR community. It proved to be excellent at creating the text regions and the baselines from our material. Logi is an HDR OCR toolkit open sourced by the No Humanities cluster in Netherlands, became our choice for HDR. Since there are several alphabets used in the catalog, there was no way for us to find a pre-trained model to suit our needs. So instead, we used and adopted a freely available Dutch model and started training. And well, this is the circular training we did. Training in Logi, and then using ourselves, humans, to correct the errors from the AI, and then pushing it back to Logi. To aid us in training the model, we arranged hackathons where curious colleagues and librarians with deep knowledge of the Catalog 62 and its peculiarities corrected errors made by the AI. To facilitate this, we installed eScriptorium, which is in itself an OCR HDR platform with a web interface. We installed this on a local server and let our colleagues correct any mistakes from the AI, and then exported the corrected results back to the AI. This went on until until the AI didn't improve any further from these corrections. So from that point, we just let the AI train more on the same type of material. And as I said in the beginning, the main goal is to make invisible collections visible. This means findable in the Swedish National Library database. And as a goal within that goal, is also to present the original digitized catalog sheets together with the transcribed texts. Yeah, as you see here, here's a part of scriptorium where the AI missed the starting C in Carol Lewis. And here's some baselines that needed corrections. Challenges during transcription and segmentation is the actual mixed typewritten and handwritten text, which posed a hinder for the AI in sometimes. And of course the handwriting styles, but also from the result to actually get the metadata from the different regions in the images. Here's a result XML from the transcribing from the AI, and you can see the types of regions that the AI has guessed correctly. One of the challenges we had was to choose an AI and a model, and also sufficient training data. We used the hackathons to get sufficient training data, which worked quite nicely. But also some coding of our own to identify metadata on the sheets. To link back to the source, this is a screenshot from a part of the Swedish National Library database, and this is just a test that we did, and this is how one of the links back to the source will look like. And at the end, I stumbled upon a IIIF recipe showing digitized newspapers with annotations, which was inspiring. And this gave us the confidence that this probably could work, and that this hopefully was yet another wheel that we didn't have to invent. We found so many on this journey. We then looked for Python code that would convert the result from the AI, which is in either page or Alto XML format, to IIIF annotations. And we found it. Actually, we found several Python scripts that did this, which was very nice for us. So we made this small proof of concept where we took a few XML files from Logi and converted them. Everything was then put together using the IIIF workbench. I think Glenn Robson was involved in that. This gave us the proof we needed that we will be able to make IIIF a part in a more or less automated pipeline. And we are very much aware that there are better and perhaps more correct ways to do this, and as we learn them, we will use them. We iterate and we refactor. We also have recently started to look at the Apache Solar OCR highlighting plugin developed by Johannes Beiter, I think, which looks very promising. So we might use that as well. And if anyone here has experience from using that plugin, I would really love a chat if you have the time. Sharing is caring. Our pipeline will mostly consist of work already done by others, and then some glue code to stick it all together. So we will naturally share anything that we create that could be useful to the community as well. And yeah, this concludes my presentation. Thank you for listening, and thanks to everyone in the community for sharing everything with everyone. It's been a key factor for the success so far in this project. Thank you.
Thanks so much for this presentation. We're going to have a few minutes